Okay. Sorry about that. I was going to record that time. Sorry. All right. Yeah. So now the part that you need now is to write the solution of the inverse. Okay. The part that you need now is to write the solution. Okay. So in inverse 3 by 3 of this example, A inverse is given by this number here, which is 112, 111, 2, 3, 4. So that's our solution. Okay. Now I said to you, we need to have this condition to be met. A inverse times A should give us I3. Okay. So multiplication of A and A inverse. So A is given by 1, 2, 1, or 1, 2, negative 1, negative 2, 0, 1, 1, negative 1, 0. And then you're going to multiply this by 1, 1, 2, 1, 1, 1, 2, 3, 4. Okay. So if you can check, this will give me, let me see. So it becomes this times that. So it becomes 1 plus 2 minus 2. That's just 1. Then I get 1 plus 2 minus 3. That's 0. And then I get, oh, sorry, you can't see. And then I get this times that. I get 2. Then 2 times 2 is just 2. I mean, 2 times 1 is just 2. Then minus 4, which is just 0. And in here I get minus 2 because this is 0 plus 2, that's 0. And I get negative 2 plus 3. Yes, negative 2 plus 3, which is this times that. And then this times that I get negative 4 plus 4. Okay, so here I take the last row and this first column, I get 1 minus 1 because of this 0. And I come here, I get this one. It becomes 1 minus 1 as well. And then this one becomes 2 times 1 minus 1. So it's 2 minus 1. Okay, so my solution hence becomes, this becomes 0, so that becomes 1. The whole thing becomes 0, so that's 0. This is 0 because it's 2 plus 2 minus 4, which is 0. Minus 2 plus 2 is 0. Minus 2 plus 3, it's 1. Minus 4 plus 4, it's 0. 1 minus 1 is 0. 1 minus 1 is 0. 2 minus 1 is 1. And therefore we get our I3. Okay. Sorry guys, that thing is a lot, but unfortunately you need to know this. Okay, you need to know this. So do I have any question, guys? Is there somebody who has got a question, an objection, yeah, and anything, Okay, so since you guys are very quiet, I'll take that you guys are okay. Right. Let us continue. Okay, so now the question is, do you see how tedious this thing is? It's a lot. It's no. Now, since this thing is a lot, and you guys, I know that you are not going to be happy with that thing, but your lecturer can ask you to solve it like this, okay? If you need to solve it like this, then you know what to do. But yeah, but if it's not specified, you know I always got shortcuts, okay? I always got shortcuts for you guys. There are many to kill a cat and there are many cats to kill. So I've got a shortcut for you. There is a way which we can find a 2 by 2 inverse without actually doing that thing that is just too much, okay? So the inverse of a 2 by 2, and I'm going to show you that the previous solutions that we got are true. Only if you wrote them. Okay? People don't write them. Okay? So let me see. So the inverse is this one. The inverse is this one. So we have it. So you're going to check if the inverse is true. Now, suppose you're given A, which is a 2 by 2, A, B, C. Okay. Now, the inverse of A will always will always, and I repeat, will always be given by A times D minus B times C. And then what you do is you make D and you bring A here, and then after that you just bring C and B. You leave them the way they are, you just give them negative values. Okay, so let us see if the thing is true. Okay, now you remember our example, we had 3547. This is from the textbook. Okay, so its inverse will be given by 1 over 3 times 7, I think is 21. 4 times 5 is 20. Okay, so that's just 1. So it's just 1 over 1. Our D value is 7. And then we leave our B alone and we give it a negative value, and we leave this one alone and we have our 3 here. So the solution A inverse is given by 7, -5, -4. Okay, let us check if this is true. If you wrote it down, please check it with me. Oh, there it is. It's 7, -5, -4, and 3. Here it is. Okay, so we can check. I said it's important for us to check. A times A inverse must give us I2. Okay, let us check. So it becomes 7 times -5 times -4 times 3 multiplied by A, which is 3547. Okay, so this should give me, so it's 7 times, what is this? What's 3? It's 7 times 3 is 21, minus 5 times that, oh, it's plus minus 20. It's plus minus 20. So, and then it becomes this and that. So it's 7 times 5 and 5 times 7. 7 times 5, I think it's 7 times 3 is, so it's 35 minus 35. Okay, it's 35 minus 35. Then the bottom part, no, why am I saying 35? Oh yeah, 7 times 5 is 35. Yeah, 35 minus 35. Okay, and then the bottom part becomes this times that. Okay, 4 times 3 is -12, and then plus 3 times 4, which is 12. -4 times 3 is -12. 3 times 4 is 12. And then the last one is negative 4 times 5, it's -20. And then 3 times 7 is 21. So as you can see, 21 minus 20 is 1. 25 minus 35 is 0. 12 minus 12 is 0. 20, -20 plus 21 is 1. Then this is I2. Okay. So as I said, there are many ways to kill a cat and there are many cats to kill away. Let us see with the second example we did. Okay. Let us see with the second example. Okay. With the second example, I gave you, or I didn't get in the textbook. I think, hey guys, who remembers the second example? I forgot the second. It's 8, 6. It's 8, 6, 5. If I can remember well. Okay. So A inverse is given by 1 over 8 times 4 is 32. 5 times 6 is 30. It's very interesting. Okay. So let me, because you have solved it. Now, as I said, D becomes A, so it becomes 4, becomes 8, it becomes -6, -5. Okay, so 32 minus 30 is 1 over 2, and it becomes 4, -6, -5, and 8. Okay, and then we need to multiply this thing by half, each and every term by half, and our A inverse is given by, what is half of 4 is 2, half of -6 is -3, half of -4 by 2, half 8 is 4. This is our solution. Okay, this is okay. Many cases. Okay, now there is a certain rule that we use, which we call the inverse using the adjoint or the transpose of a matrix. The adjoint or the transpose of a matrix. This, you know, when I tell you about the adjoint and the transpose of a matrix, those things are there to make those long methods to be very short. Okay, Look at this method. It's very easy, guys. It's very easy. And this method is given by, we call the bottom part here. You see this part where we are subtracting here. We call that part the determinant. Okay, determinant. So let us do a little bit of determinant. Let us see what is this determinant. Okay. So guys, did you understand how the easy one goes? Okay. But if you didn't, you'll find this video on YouTube. But if you still feel like I was moving too quick also on YouTube, you can play this slow motion. I mean, you can say, yeah, I can send a message. Okay, I'll deal with that. Okay, the determinant of A is given by A absolute value of A, but it doesn't mean that the solution has to be positive. We just use this to denote determinants. Okay, this is just for us to denote determinant. Okay, so this is what we use to denote determinant. So determinant of A, if A is this, it's always given by A times D minus B times C. Okay, so yeah. A determinant of 2 by 2 is very easy. Let us now find determinant of 3 by 2. Okay, so in A is given by, let me say it's A1, B1, C1, A2, B2, C2, A3, B3, C3. Okay, so its determinant, A determinant is given by, you are going to always say A1, right? Then you are going to multiply B2, C2, and then B3, C3. What I mean by that is, when you choose A1, right? A1, you are going to close everything else that has to correlate with A1. To close this one. So the only things that you can multiply is this one, okay? And then you're going to subtract. Then you're going to say B1. Now you see, also when I take B1, what happens? I have to close this and this part. What is left? What is left is this one. The ones that I didn't close, this one. So it becomes A2, C2, A3, C3. Okay, and then when I take the C1 part, if I take the C1 part, this one, so I have to close these ones, this one. So it becomes A2, B2, A3, B3. Okay, now another thing that you need to be aware of, guys, is that when you take these values of A1, B1, and C1, they must alternate. You always start with the positive, a negative, a positive, a negative, a positive, a negative, a positive, a negative. It's very important for you to note. You're going to see why I'm saying that, because you're going to do this thing called the adjoint. And the adjoint is very crucial when it has to come to its signs. So their signs are very, very important. Okay. So let us have one example. Let us have one example for 3 by 3. A 2 by 2. Okay, do these ones for 2 by 2. Okay. Let me, which numbers do you like, guys? Which numbers do you like? Okay, let me have 3, 5, -4, and then do this one as well. I want you to just find the determinants. If you want, you can find its inverse, okay? If you want, you can find its inverse. 8, 4, and -3. Okay? Now, let us go back to our calculator. You remember, I said to you, we can find the solutions to this, okay? A matrix, so 7, determinant. Determinant is given by determinant of matrix. Okay. Okay, let me go back here. Say determinant of matrix. Okay. So the determinant of matrix A is given by 1. Okay, and matrix A, remember what is matrix A, guys? Okay, let me go back and show you what is matrix A. Matrix A is that question that we have now, 3, 5, 4, and 7. Okay, which is that one I just saw. Where is it? Sorry about that. Okay, yeah, 3, 5, 4, 7. Okay, so 3, 5, 4, 7 Let me write it down here. 3547. This one, 3547. This is A. Its determinant is given by, its determinant is given by 3 times 7, which is 21, and then minus 5 times 4, which is 20, which is equals to 1. And it correlates exactly to, okay, let me this, guys, sorry about that. I've got a lot of, so this is 7, which is determinant, okay? Determinant of, we're going to shift matrix, and then we choose matrix A, which is the number 3, okay? And then the solution is 1, okay? I don't know if you can see it, guys. The solution is 1, which correlates to this. If you have this calculator, you have all solutions. That's what I'm saying to you, okay? That's what I'm saying to you. Let us have the determinant of a 3 by 3. Just one example, and then we get done. I don't want us to stay too long, okay? Because we still have adjoint to do. If we can complete adjoint today, okay, then we'll be done with, yeah, okay. So I'm going to give you some questions to go through, okay? I'm going to be specific on my solutions. I want solutions to be certain, okay? Because, so let me have, let's say 2, 4, negative 3, 5, 7, 6, 8, 1, 9. Okay, so let's say this is matrix B. So I want you to find the determinant of B. Determinant of B is going to be given by 2. Okay, then we're going to close these ones. We're left with 7, 6, 1, 9. Okay, minus 4. Remember, they must alternate. Okay, we close these ones. We're left with 5, negative 8, 6, and 9. And then plus negative 3. Then we're left with 5, negative 8, 7, and 1. Okay, so now we need to find that solution. So it becomes 2. 7 times 9. Ish. Okay, let me see. It's 7. It's 7. It's 9. Okay, 7, it's 9. So it's 1, 2, 3, 4, 5. It's 63. 63 minus 6 times 1, which is 6. Okay, minus 4. 5 times 9 is 45. This one I knew it. It's 45. And then 6 times 8. Okay, let's find 6 times 8. So I'm going to have 6. I'm going to have 8. So I'm going to have 1, 2, 3, 4. So it's going to be 48. So it's going to be positive 48. And I'm going to have minus 3. 5 times 1, which is 5. 2 times 7, which is 14. So it's going to be 5 plus 4. Okay. Oh, no, it's 8. It's not 2. Why? Oh, Jesus. 8. So 8 times 7. So let me go back. So it's 8. It's 7. So it becomes 1, 2, 3, 4, 5, 56. So it's 56 here. Okay. So the solution becomes 2. Okay. So it becomes 60 minus 6. It's 54 plus 3. It's 57. Minus 4 times 45 plus 48. 93. Minus 3 times 61. Okay. And then this, I think 2 times 57. I think it's 114. 14. I think 4 times 93 must be 372. And then it's 180 plus that, which becomes 180. Okay. So 3 times 61 is 183, guys. I'm not sure. I'm just going through these things. So you will tell me if my solutions are correct. Okay. So if it happens that the solutions are not correct, then I don't know. So this becomes 408 plus 7. It's 15. So it's 5. It's 5. It's 15. It's 4. 4 minus 1 is 3. 5 minus that is, oh no. So this is 4, this is 500. Okay, so it's negative. So it's 144, I mean 114 minus 555. So it's going to be oh, let me write it. 5 minus 1 it's 4. 5 minus 1 is 4. 5 minus 4 is 1. So the solution should be a negative 441. 441. So when you find that solution, you let me know. Okay. So let me give you yours. Let me give you yours. Okay. So you can find the ones for C. C is given by 5. Let me say 5, 7, and negative 8. 4, negative 3, and 6. 1, 7, and negative 9. Okay. So guys, you guys, when I give you these things, you don't even bother to do them. Okay, it's fine. It's fine. But remember that the same thing that you are doing to me is the same thing I'm going to do. And then the next thing you come when you write your test, you are saying, I think I can't solve this one and stuff like that. I can't help you on the test. But if you try doing these things on your own, I can help. On the test, I can't do anything. See. So people will text me and say, please help me with this. I can't help you. I can't help. It's out of my hand. Okay. Now let us do the last part, transpose and adjoint. Okay. Let us do the last part, transpose and adjoint. Whoo! That is a lot. That is a lot. So you guys will tell me, okay, if whether you need any session to revise everything that we have done in terms of matrices before you do your assignment, or we should just release the assignment. Okay. If you feel like you're ready, you can release the assignment, you can start. So you guys will decide, okay? So what do you decide actually? Do you decide that we do that now, or like Monday I should have a session to help you do matrices again, and then you start your assignment, or you just start your assignment? So you guys will take. Okay, so now we're having this idea. Now I'm gonna give you the easiest way to solve a 3 by 3 matrix. Okay, this is how you're going to solve it. Hi. It's a bit longer, but it's longer than that one of writing R1 minus R5 to 7 R10 8, that one. Now, this is the A inverse of a 3 by 3 is given by 1 over the determinant of A, okay, multiplied by the adjoint of A. Or if you don't want to write adjoint of A, you can write A transpose. Okay, adjoint of A transpose. Okay, so let me have an example. Okay, let me have an example, and let's see whether it is true. And remember, always remember that A multiplied by A inverse will always give us I3 for a 3 by 3. Okay, for a 3 by 3. So where's my pen? Oh, all right. So I've got A. Let's say it's given by 0, 0, 1, 2, negative 1, and 3. Then let's have 1, 1, 4. Okay, let's have this. So the inverse in this case will be given by. Now, the first thing first, you need to find or determine the determinant of A. Okay, so the determinant of A is going to be easy because this is 0, and the only thing is going to be given by that one. It's going to be 1 multiplied by 2, 1, negative 1, and 1. Okay, so this will be given by 1 times, okay, we don't write 1, we're going to write this minus that. Okay, so it's going to be 2 plus 1, because it's 2 minus 1, which is just 3. Okay, so this is what is given as our determinant. Okay, now we're going to do something called the adjoint. The adjoint is, so guys, the adjoint is given by a huge thing here. So let me write it like this. So the first adjoint will be given by a positive. It's always given by a positive. Okay, it's always given by a positive. And then we're gonna take the first values, which are these one. Okay, take the first values, which is -1, 3, 1, 4. We're gonna determine its determinant. The second one will be given by a negative. Alternation. Alternation. There's no such thing as alternation. The second one will be given by, now we're going to close this one, and then we're going to have 2, 1, 3, and 4. Okay, and then we're going to have that's here, and then we're going to have we're going to close this one, so we're going to have this one, which is given by 2, -1, 1. Okay, this is called the adjoint. Adjoint is another thing, but it's a nice thing. It's a very nice thing. Okay, so what do you think is the next sign? It has to alternate, right? So the next sign has to be a minus. But in this case, we are not just taking anything. We need to be very specific. Okay, we do not just take. So now we're going to close these ones. We're going to take 0. We're going to close this. We're going to take 0, 1, 1, and 4. Okay, 0, 1, 0, 1, 1. Okay, so you see what happened there, guys. If you don't understand it, please do let me know. You understand what is going on here, guys? Okay, this is what happens. This correlates to this number, right? When it correlates to this number, we're going to take these ones, we close them up. Okay. So what is the numbers that are left? It's 0, 1, 1, and 4. The next value is correlating to this one. So we have to close this one and this one. And then what are we going to have? We're going to have, okay, let me have the plus here first and have the absolute value. So it becomes 0, 1, and then you're gonna have 1 and 4. Okay. And then the next one, there has to be a minus. Okay. Then we have the absolute value. So now we're going to close this one and this one. So you're gonna have 0, 0, 1, 1, 1, 0, 0. Okay. Then we're going to the last one. Woo! This thing is a lot. Now we correlate to this one. So we're gonna close this and that. So we'll be left with 0, 1, -1, and 0, 1, -1. Okay. So now this step you can skip it, guys. Okay, you can skip this step. I'm just doing it because I want us to understand. Okay, just doing it because I understand. And we're left with 10 minutes. Okay, so now we've got this one. Then we take 0, 2, 1, 0, 2. Okay, so the last one is a plus. Whew. Then we're going to close this one. I get it correlates to this 4. So we close this one. We're left with 0, 0, 2, and negative. You see, so there's correlation. If I take this one, I close this, everything that is correlating to the 3. If I want this one, I close everything that correlates to the 0. Okay, it has to go like this, Okay, now there's whatever solution that I'm going to find here, it's going to give me a matrix. Okay, it's going to give me a matrix. So let us see what matrix we get. Okay, so it's going to be -4 minus 3, which is -7. Okay, and then we're going to have 2 times, which is 8. 8 minus, it's 8 minus 3, which is going to be -5. Okay, so let me just write it as negative. Now, do you see where this negative comes from? Oh, let me not just write it as negative. I want you to understand. And then we have 2 times 1, minus 1, so it becomes a +3. Okay, and then we have 0 times 4, which is 0 minus 1, which is minus 1. And then we got 0 times 4, which is 0 minus 1, so it becomes -1. 0 times 0 minus 0, which is just 0. Then you have 0 times 3, which is 0 minus that one, it becomes a positive. Then this times that, it's 0, 2. So it's 0 minus 2 minus, so it becomes negative 2. Then it becomes 0 times that, and then this is just C. Okay. So the matrix, this matrix is exactly equivalent to -7, and then this becomes -5, 3, and this becomes -1, -1, 0, 1, -2. Okay. After finding this one, we are going to perform what we call A transpose. A transpose. What A transpose does is it keeps this one to be the same. Okay? It keeps it to be the same. After what is here is going to come that this here is going to come this. Okay. It's more like switching, switch. Okay. It's just that I can't stay too much on that one. Okay. So let me just write A transpose is equals to. Now, as I said, A transpose stays the same. Okay. It becomes -7, -1, 0. The diagonal stays the same. Okay. So I'll give you another way for you to think about it. Okay. 3, 0 here. Then I've got 1. I've got a 1. I've got a 2. Okay. So this is the A transpose. So therefore, our solution, A inverse. Oh, this thing is a lot, guys. 1 over absolute value of A, not absolute value, determinant of A, which is 3. 1 over determinant of A, which is 3. And then you multiply by -7, 1, 1, -5, -1, 2, 3, 0, 0. Okay. 3, 0, 0. And then you just multiply each and every term by that. So it gets -7 over 3, 1 over 3, 1 over 3, -5 over 3, -1 over 3, 2 over 3, 1, 0, 0. Okay, so this becomes your inverse. So you can check if this inverse is true. Okay, so guys, what I'm trying to say to you is, yeah, this becomes the solution. There's nothing else we can do from here. This becomes the solution. Okay, so another way for you to think about transpose. Now, this is what transpose does. If I'm given A, B, C, D, E, F, G, H, I, this is A. A transpose is just what we had, okay? But whatever that was the row should be a column. So it becomes A, B, C, and then it becomes D, E, F, and it becomes G, H, and I. So A transpose is just A, but whatever that was column should become. So guys, thank you very much for attending today's session. Do you have any questions? Guys, I gave you too much information for us to, for you to take all in at once. So I'm just gonna relax and let you do this thing over the weekend. But guys, for now, thank you so much for attending the very last session. You guys will let me know if we need a session on Monday. But for now, thank you very much. Enjoy the rest of the day. And please take care of yourselves. Practice, guys. We'll speak in the group chat. Do you have any questions before I end this session? So I'm gonna upload more examples.
Could you
Yes, my guy.
could you like post this video onto your YouTube channel like after you can zoom out so that we can ask you questions if we encounter it them?
Yeah, no problem. I'll do so right now. Okay, I'll do so right now. And then I'll do some examples for you, upload them there on the group chat, and then you'll tell me if you need any other. Okay. But for now, thank you guys for attending. Thank you very much. Enjoy the rest of your day. Thank you.